So composite area using triangles, part 2. All right, so basically we have this shape, and we are going to divide it into triangles and find the whole area of it. So if you look here, I have one triangle here with the altitude dotted. You could call that 2 separate triangles, but I think one would be less math. And then we have a second triangle here. So you call them what you like. I like to letter them. So this would be triangle A, and then this one can be triangle B. So let's find the area of triangle A. The formula is 1/2 base times height. All right, so I look here at my triangle A, and I see that I know this side. So let's call that our base. And then perpendicular to it, I have this dotted line that it has the measure of 10. So I have my base and my height. I'm just trying to move this over so I can write down the answer. So 12 times 10 is 120, divided by 2 is 60. So here I write 60 is my area, and we're doing inches. And so 12 inches times 10 inches, that's inches squared. Okay, we only square our units. We do not square the number. You would not write 60 squared, okay? Okay, so that's our triangle A. So now let's find the area of triangle B. We know that's 1/2 base times height. So here I have a right triangle, so I know that the base and height are those perpendicular sides. It doesn't matter, I could call the side one base, or the 6-inch base and the tall one the height, whichever you want. I'll call the 6 the base, just because it's horizontal and the vertical is the height, but they're not always. Sometimes they're off on, other directions. Well, this doesn't have a label on it, but so I look over here and I can see that this same distance is 10. So this is 10. The height is 10. So my area is 1/2, 6 is 3, times 10 is 30. And again, we have inches squared. And again, we only square the units. We do not square the number. If you write 30 squared, that's not the same thing as 30, and so that would be a wrong answer. Okay, so then let's find our total area. By adding the areas that I already have here. So we have 90 inches squared. So we added those two together. So this would be the area of our composite figure. Okay, let's do another one. All right, this one you might look at it and think I could find the area of this way better with rectangles, but we are doing triangles. We're using triangles today, and so I've already divided this up into triangles. And we're going to find the area of each triangle and add them all up for this total area. Okay, so let's just start here. This is triangle A. So the area of A is 1/2 base times height. Okay, so my base on this one is 3. The height is the side that's perpendicular to it. There isn't a label here, but I do just look right over here, and I see that this same height is 3. So I know my height in this triangle is also 3. So 1/2, 3 times 3 is 4.5. My units are millimeters. And of course, I'm going to square the units, but not the number. Okay, let's go to triangle B, the next triangle. So find the area of triangle B is 1/2 base times height. And I can see that it still have the 3 and the 3 that's down here as well. So that one was super duper easy. Moving on to triangle C. It's nice when you have right triangles because you can just use the sides of the triangles. Okay, so my base is 3, but the height is not there. So I'm going to take my eyes and go to the other side of the figure and notice that I don't have anything that's exactly like this, but I do have this 2, and then I have this right here is 4. So some of this is 2, but then the rest is 4, so that's 6. Does everyone understand how I got that 6? Okay, so I have 3 and 6 are my base and height. Okay, so 1/2, 3 times 6 is 18, divided by 2 is 9. And then we, again, square our units, but not the number. All right, let's do the next triangle. Oops, that's not a C. It should be a D. Area of triangle D is 1/2 base times height. Oh, well, this triangle is not a right triangle. So this is obtuse. This is an obtuse angle. So remember, sometimes our altitudes are outside of our triangle. And looking at this triangle, I see that this 9 is one of the sides of the triangle. So I'm going to use that as my base. Okay, then I'm going to go to the opposite vertex. And then I want to drop, like say I stood up there and just dropped something straight down. And it landed at the same level as my base. So that's going to be my height. And that's the side that I just found out was 6. Okay, so I have a question about the 6. So when I see this side, there's no number there. But when I look over to the other side, I know that that's 2 and that is 4. So that's right here is where I'm looking, that 2 and that 4. So I know the whole thing would be 6. All right, so 9 times 6. How about 9? Half of 6 is 3, and 3 times 9 is 27. Again, we square our units, but we do not square the number. Next triangle, that would be E. So the area of triangle E is, again, 1/2 base times height. Another obtuse triangle. So our height is not going to be in the triangle or on the triangle. We have to find it. So I do see that this 4 is one of the sides of the triangle, so I'm going to use that as my base. And then I need to go to the opposite vertex, and I want to say I turn this sideways. Well, it doesn't, when I turn my iPad, the whole thing turns anyway, so it doesn't. But if I were to turn this and then drop straight down, I would stop right here, and that would be the height for that triangle E. It's like the picture from the first one. Okay, so how long is that? Because the whole thing is 14. It's 12 because this little section right here is 2, so it's 14 minus 2, so it's 12. All right, so we've got the numbers for that triangle, and we have 1/2 times 4 is 2. 2 times 12 is 24 millimeters squared. All right, let's go to the next triangle. That would be DEF, area of triangle F. Okay, so this whole side of that triangle is 14, 1/2 base times height. So I'll use that as my base, because the height is not always a side, so it's helpful if you know this one of the sides of your triangle. And then I'm going to go to the opposite vertex from that base, and then I have to go perpendicular for the altitude / height. Okay, so how long is this height? Well, it's the same as this right here, so that would make it a 2. Okay, so for 1/2 times 2 is 1. 1 times 14 is 14 millimeters. Again, I square the units and not the number. Okay, so the next triangle I have will be triangle G. So this triangle is not part of, that's already part of this whole triangle, so I don't want to confuse myself. So that's that, and then G's over here. So G is a right triangle, so we end up on the easy kind. So I take the two sides, the 2 and 2, and those will be my base and height. And 1/2 and 2 cancels out, so we're left with one of the 2's left, so it's 2 millimeters squared. All right, so now we just take all of these areas of triangles and add them all up to get our total area of the composite figure. So, somebody want to get out their calculator? And I'll read them out loud. 4.5 plus 4.5 plus 9 plus 27 plus 24 plus 14 plus 2 equals 85 millimeters squared. Again, you square the millimeters, not the number.